Imagine holding a weapon so sophisticated, so chemically precise, that it required knowledge modern humans wouldn't rediscover for another 56,000 years. Now imagine that this weapon was crafted not in a laboratory, not in a university, but in the heart of ancient Africa 60,000 years ago. On January 7, 2026, scientists dropped a bombshell that should rewrite every history textbook on Earth. In a cave in South Africa, they found something that shatters our understanding of human intelligence, innovation, and the very origins of science itself. This is the story of how Africa may have been humanity's first scientific civilization. And the evidence? It's been hiding in plain sight for 6 millennia. Picture this. It's 58,000 BCE. The last ice age is tightening its grip on the planet. Neanderthals still roam Europe. Modern humans are just beginning to spread across continents, and in a rock shelter in what we now call KwaZulu-Natal, South Africa, a hunter is doing something extraordinary. They're not just sharpening a stone arrowhead, they're coating it with poison. But not just any poison. This hunter has identified a specific plant, Boophone disticha, extracted its most toxic alkaloids, buphandrine and epibuphanisine, and carefully applied them to quartz arrow tips. This isn't luck. This isn't accident. This is chemistry. This is botany. This is pharmacology. And it's happening 60,000 years ago. For decades, we've been taught that science began in ancient Greece, that civilization started in Mesopotamia, that Africa was somehow late to the game of human innovation. But what if we've had it backwards this entire time? What if the world's first scientists weren't wearing togas in Athens, but were tracking game across the African savanna with weapons that would make a modern chemist proud? The discovery came from Umhlatuzana Rock Shelter, a site that archaeologists have known about for years. But in 2026, a team led by Professor Sven Isaksson from Stockholm University, Professor Marlies Lombard from the University of Johannesburg, and Professor Anders Högberg from Linnaeus University decided to look closer, much closer. Using cutting-edge chemical analysis, they examined residues on ancient stone arrowheads. And there it was, buphandrine, a toxic alkaloid that can cause respiratory paralysis, lung edema, and death within 20 to 30 minutes in small animals. The same poison that traditional South African hunters still use today, 60,000 years later. Think about that timeline for a moment. When these arrows were made, humans hadn't yet painted the Lascaux caves. We hadn't built Stonehenge. We hadn't invented writing, agriculture, or the wheel. But we were already master chemists. The researchers tested 5 arrowheads from 60,000 years ago. Every single one showed traces of the poison. This wasn't a one-time experiment. This was established technology, standard practice, cultural knowledge passed down through generations. And here's where it gets even more mind-blowing. They also tested arrowheads from the 1700s CE found in the same region. Same plant, same poison, same technique. That's 60,000 years of continuous scientific knowledge. For context, that's 12 times longer than all of recorded human history. Now, before we go further, I want to say a big thank you to our new subscribers. Your subscriptions and engagements on our previous video was indeed supportive and a positive start to this community. And if you're new here and finding this story as fascinating as I am, hit that like button and subscribe. We're diving deep into hidden histories and forgotten innovations that challenge everything we thought we knew. Trust me, you won't want to miss what's coming next. So, what does poisoning an arrow actually require? Let's break down the science. First, you need observational biology. You have to notice that certain plants make animals sick or kill them. That requires systematic observation over time, probably across generations. Second, you need botanical identification. Boophone disticha looks similar to several other bulb plants in southern Africa. You have to know exactly which one contains the poison. One mistake and you've wasted your hunt, or worse, poisoned yourself. Third, you need extraction chemistry. The most toxic alkaloids are concentrated in the bulb of the plant. You have to know where to find them, how to extract them, and how to prepare them for use. This isn't grinding up leaves. This is understanding plant chemistry at a molecular level, even if you don't have words for molecules. Fourth, you need dosage knowledge. Too little poison and the animal escapes. Too much and you risk contaminating the meat. You need precision. Fifth, you need delayed effect strategy. These poisons don't kill instantly. They weaken prey over time. That means these hunters understood persistence hunting, tracking wounded animals sometimes for hours or days, waiting for the toxins to do their work. This requires planning, patience, and an understanding of biological systems. Sixth, you need preservation techniques. How do you keep poison potent? How do you store it? How do you transport it safely? These are questions that require experimental knowledge. And seventh, you need information transfer. All this knowledge has to be taught, preserved, and passed down with enough precision that people 60,000 years later are using the exact same plant in the exact same way. This isn't primitive. This is sophisticated science. But the poisoned arrows are just the beginning. Once you start looking at Africa through the lens of, what if this was the first scientific civilization, the evidence piles up like layers of sediment in an archaeological dig. Consider the Blombos Cave, also in South Africa, where archaeologists found 100,000-year-old ochre processing kits. These weren't just random pigments. Ancient Africans were mixing minerals, heating them to specific temperatures, combining them with bone marrow and charcoal to create paints with precise properties. That's materials science. That's chemistry. Or look at the discovery of the world's oldest known drawing, found in Blombos Cave in 2018, dated to 73,000 years ago. It's a geometric pattern drawn with ochre on a piece of silkcrete stone. Abstract thought, symbolic communication, mathematical pattern recognition. Then there's the Border Cave in South Africa, where researchers found 40,000-year-old wooden digging sticks with precisely carved handles still preserved. These weren't crude tools. They were ergonomically designed instruments that showed understanding of leverage, material properties, and tool efficiency. In Sibudu Cave, also in KwaZulu-Natal, archaeologists discovered 77,000-year-old evidence of bedding made from sedges and other aromatic plants. But these weren't just comfortable. Chemical analysis showed these plants had insecticidal and larvicidal properties. Ancient Africans were using pest control chemistry 77,000 years ago. The same site yielded evidence of compound adhesives from 70,000 years ago, combining red ochre with plant gum heated to specific temperatures. This is advanced materials engineering requiring precise temperature control and an understanding of chemical bonding. And let's talk about the oldest known mine in the world, Ngwenya Mine in Eswatini, where humans were extracting hematite and ochre 43,000 years ago. Mining requires geology knowledge, engineering for excavation, and logistics for resource management. Here's what really gets me. All of this represents something we don't usually associate with primitive humans. It represents the scientific method. Think about how you develop poison arrow technology. You don't stumble into it. You experiment. You observe results. You refine techniques. You test variables. You pass on knowledge. You iterate across generations. That's hypothesis testing. That's empirical observation. That's peer review, just conducted around campfires instead of in academic journals. When we teach the history of science, we usually start with the ancient Greeks, Aristotle, Pythagoras, Archimedes. But those guys were working around 300 BCE. The African poisoners beat them by 57,700 years. We talk about the Islamic Golden Age, when scholars in Baghdad and Cairo preserved and expanded scientific knowledge. That was around 800 CE. The African poisoners had already been refining their craft for 58,800 years by then. We celebrate the scientific revolution in Europe when Galileo and Newton formalized the scientific method. That was around 1600 CE. By then, African communities had been conducting systematic chemical experiments for 59,600 years. What if Africa wasn't behind in the development of science? What if Africa was so far ahead that we simply forgot to look? Now, I know what some of you might be thinking. Sure, they had poison arrows, but they didn't have writing or cities or monuments. How can you call that a scientific civilization? And that's exactly the bias we need to challenge. We've defined civilization based on what Mesopotamia and Egypt and Greece and Rome did. Writing, cities, monuments, empires. But what if that's just one path? What if there are other ways to build sophisticated societies? The poison arrow evidence suggests that ancient Africans chose a different path. They developed deep, intimate knowledge of their environment. They built their civilization on understanding ecology, biology, chemistry, and sustainable living within natural systems. They didn't need to write down their chemical formulas because they embedded them in cultural practices, in songs, in stories, in hands-on teaching that proved so robust it survived 60,000 years. That's more durable than any clay tablet. They didn't build massive monuments because their technology focused on efficiency and sustainability, not permanence and domination. They worked with nature, not against it. And you know what? That might actually be a more advanced approach. After all, their civilization lasted 60,000 years. Mesopotamia lasted a few thousand. Rome lasted a few centuries. Our modern industrial civilization is only about 200 years old, and we're already facing existential environmental crises. Maybe the real measure of a civilization isn't how big its monuments are, but how long it lasts, how sustainable its relationship with the environment is, how deeply it understands the natural world. One of the most stunning aspects of this discovery is the continuity. When those researchers tested arrows from the 1700s, they found the same poison from the same plant used in the same way. 60,000 years of unbroken knowledge transfer. Think about what that means. While empires rose and fell around the world, while languages evolved and died, while religions emerged and transformed, while technology revolutionized and revolutionized again, this knowledge persisted. Through the last ice age, through massive climate changes, through the migration of peoples, through colonial invasions, through everything history could throw at it, this scientific knowledge survived. That's not primitive. That's incredibly sophisticated. It suggests systems of education, cultural practices, and knowledge preservation that are far more resilient than our written records. After all, we've lost most ancient texts. We can't read many ancient languages. We've forgotten countless technologies. But in southern Africa, they never forgot how to make poison arrows. So, what if we rethink the entire narrative of human civilization? What if the story isn't humans slowly progressed from primitive Africa to advanced civilizations elsewhere, but instead, humans developed sophisticated science in Africa first, and then some populations migrated and took different technological paths? What if the first scientists weren't Greek philosophers, but African hunters who understood chemistry so well they could extract specific alkaloids from specific plants and use them with precision? What if the first engineers weren't Roman architects, but African toolmakers who designed ergonomic instruments and developed compound adhesives? What if the first pharmacologists weren't medieval alchemists, but African healers who knew which plants could kill, which could cure, and how to use them safely? The evidence keeps mounting. In 2019, researchers announced that Homo sapiens evolved earlier than previously thought, with fossils from Morocco dated to 315,000 years ago. In 2021, archaeologists working in Kenya found the oldest known human burial in Africa, dated to 78,000 years ago, showing complex mortuary practices and symbolic thought. In 2022, stone tools from Algeria were dated to 2.4 million years ago, among the oldest ever found. And genetic studies consistently show that human genetic diversity is highest in Africa, confirming that this is where our species spent most of its evolutionary history, developing, innovating, and creating. Here's something else to consider. If Africans were the first to develop poison weapons technology, what happened when humans migrated out of Africa? We know that indigenous peoples around the world developed poison arrow and dart technologies. Australian Aboriginal peoples used plant toxins on their weapons. South American tribes developed curare. Asian communities created numerous poison formulations. What if all of these traditions trace back to that original African innovation 60,000 years ago? What if poison weapon technology was part of the toolkit that humans carried with them as they spread across the globe? If that's true, then this isn't just African history. This is the foundation of global human technology. The African poisoners weren't just the first in Africa, they were the first in the world, and their innovation echoed across continents and millennia. This discovery also has profound implications for how we think about traditional knowledge today. In modern times, pharmaceutical companies regularly search for new medicines by studying plants used in traditional healing practices. This is called ethnopharmacology, and it's produced numerous life-saving drugs. But here's the thing. We usually treat traditional knowledge as folk wisdom, interesting but unscientific. We think of it as something that needs to be validated by modern science. The poison arrow discovery flips that narrative. Traditional knowledge isn't pre-scientific, it is science. It's 60,000 years of systematic experimentation, observation, and refinement. When a traditional South African hunter says, "Use this plant for this purpose," they're not sharing folklore. They're sharing the results of 60,000 years of empirical testing. That's a longer research period than any modern scientific study could ever achieve. Maybe instead of validating traditional knowledge with modern science, we should be learning from it. Maybe these knowledge systems have things to teach us about long-term thinking, sustainability, and working with natural systems. We also need to talk about why this discovery surprises us. If archaeologists had found 60,000-year-old poison weapons in Europe, would we be shocked? Or would we immediately start talking about how advanced and innovative ancient Europeans were? If these arrows had been found in Asia, would we question whether this was real science? Or would we celebrate it as evidence of ancient genius? The fact that this discovery surprises us reveals our own biases. We've been taught, implicitly and explicitly, that Africa was somehow behind, that innovation happened elsewhere and only slowly spread to the dark continent. But the evidence doesn't support that narrative, not at all. Africa is where we became human. Africa is where we developed language, art, music, and symbolic thought. Africa is where we first created tools, controlled fire, and built shelters. And now we know, Africa is where we first became scientists. The colonial lens taught us to see Africa as primitive, but what if that lens was wrong? What if we've been looking at human history backwards this entire time? If this story has challenged the way you think about history, about Africa, about science itself, do me a favor. Hit that subscribe button. Click the notification bell, because we're going to keep digging into these hidden histories, these forgotten innovations, these stories that change everything we thought we knew. Share this video with someone who needs to hear it, because this isn't just interesting history. This is about reclaiming the truth of human innovation. Those arrowheads sitting in a South African laboratory aren't just ancient weapons. They're evidence of humanity's first chemical experiments. They're proof that science didn't begin in Greece, or Arabia, or Renaissance Europe. Science began in Africa, 60,000 years ago, when someone looked at a plant and thought, "I wonder if I can use this to make my hunt more successful." And then they tested that hypothesis and refined it and taught it to others and created a tradition of knowledge that survived 60,000 years. That's longer than civilization, longer than agriculture, longer than cities or writing or empires. When we ask, what if Africa was Earth's first scientific civilization? We're not engaging in speculation. We're following the evidence. And the evidence is clear. Africa didn't just give birth to humanity. Africa gave birth to human science. The next time someone tells you that Africa was late to the game of human innovation, you can tell them about the poisoners of Umhlatuzana. You can tell them about 60,000 years of unbroken chemical knowledge. You can tell them about the world's first scientists. Because they weren't wearing white lab coats in European universities. They were crafting poison arrows in the heart of Africa, mastering chemistry millennia before the rest of the world even knew what chemistry was. And that changes everything. What do you think? Does the evidence convince you that Africa was indeed the first scientific civilization, or do you have a different theory? Drop your thoughts in the comments below. I read every single one, and I love hearing different perspectives on these discoveries. If this story opened your mind even a little bit, share it with someone who needs to hear it. And remember, history is written by the victors, but archaeology doesn't lie. The stones remember, the residues remain, and the truth, eventually, always comes out. Until next time, keep questioning, keep exploring, and never stop digging for truth.